So, to just like put it up, like friendship finder is a thing we have done a few times on campus. It is sort of like a survey form, comes out 50 questions are there, people fill it and we match them with whom we believe would be their best friend on campus.
And it went like
Again, like how hard would it be? That was 15 months ago. You know a few algorithms. Haskell code. Haskell is a functional programming language. Have everyone heard of Haskell? Are there people who have not heard of Haskell? Please raise your hand. Lovely. You get to hear about a new language, which is perhaps my favorite language. Therefore, introduction to matching theory. First, we'll go to the algorithms part of all this. In 2012, we had one of the biggest upsets of Nobel Prize history, where Alvin Roth and Lloyd Shapley received the Economics Nobel Prize. A name which was missing here was Gale, David Gale, because David Gale had died and we cannot give a Nobel Prize posthumously. This prize was given for something called the Gale-Shapley algorithm. Very sad. So let's look at a slightly easier problem than whatever we'll do. Given n men and n women who are all heterosexual and have a complete preference ordering over the other, can we match them nicely?
What is difference?
Men who prefer women and women who prefer men.
Okay.
Right?
So why is super like why is dangerous term is there?
Why this?
Unknown term.
Because there exists another term called homosexual. Men who like men, women who like women.
Huh? What?
Every day we learn. Okay. Question which I was more expecting was what is a nice matching mean? So it could mean a lot of things, right? It could mean a popular matching. As in after we give everyone a match, we ask people to vote. Are you happy? Are you happy or not? If more than half the people say like they are happier than in any other matching, like if I get another person give another matching, and the voting happens and my matching will win against anything, then it's a popular matching. There's something called maximum matching where the saddest person happiness is maximum. There's a Pareto matching. I do not want to define that. Unfortunately, finding all of these is NP complete. NP complete for the uninitiated means cannot be done quickly enough. Sad. However, there is one type of matching which could work. That's it. That's called stable matching. A stable matching M on men union women is stable. Matching means one man, one woman. And we have a tuple over here. For all M in M, for all W in women, and for M W dash, comma M dash W in the matching, M prefers their match over the other person, and M dash prefers their guy over the other guy. Basically, there is no case where this person and this person can just run away together. W dash and M dash cannot run away together. One of them will object to it. This will all we do. And same with M and W, they both won't run away together. This is all it means for us. And how do we find this matching? This is called the method of deferred acceptance or Gale-Shapley algorithm. It's an example of a greedy algorithm per se. Okay, what's the most simple way of doing so? We just make a matching. If something breaks, we delete that and we move and we try again, right? Simply speaking, a greedy sort of strategy. Yeah, someone got a Nobel Prize for saying that. They got for a lot. Let's say there are 4 males and 3 females in a party. Let's name these people Sheldon, Leonard, Raj and Harvard, and Penny, Amy and Bernadette. Please note, despite whatever, this has nothing to do with any heavily copyrighted shows you might have be in any familiarity with.
Nothing.
Yeah, you know nothing. Yeah, you were just names. Random names. Yeah. So, let's say what we'll do is boys who are without any match propose to the top girl who is yet to reject them. Each girl rejects all but the favorite offer she received in this round plus whoever she is with, right? Provisional match. Each boy crosses off the rejecting girl from their list. Repeat till everyone have a match. For example, Raj, if top girl is Penny, Penny have no other offers right now, so she'll be like, okay. Sheldon's top girl is Amy, she's like, okay. Leonard now proposes to Penny, and Penny prefers Leonard over Raj. So, and Howard also proposes to Penny. Now girls, Leonard likes Penny, so Penny likes Leonard, so yeah. Raj cancels off Penny, rejected. Howard cancels off Penny, rejected. Okay. Next round. Raj proposes to Amy, Howard proposes to Bernadette, and Raj cancels off Amy. Now Raj will also propose to Bernadette. Unfortunately, Raj will remain single. Again, nothing to do with how the show turns out. There is no show we are talking about, right? Yeah. So, does the algorithm make sense? What's happening? Everyone makes a round of proposals, then there happens a round of rejection, and we keep track doing this. Now, it is clear that at most n into m proposals can be made, and hence O of n into m updates need to be made. Hence, if equal number of men and women, then O of n square proposals, and the algorithm runs in quadratic time with the appropriate data set. What about correctness? Please note, this shows termination, right? We cannot have more than this proposal. It will terminate. That's one guarantee we get. No? What about correctness? What if the correctness that whatever we are claiming is stable? Simple. Lemma 1. Proof for all women their provisional match in round T plus 1 is better or equal to their match in round T. Proof is obvious by induction, because you wouldn't have, like you wouldn't except
Shows in round T plus 1.
Yeah. Exactly. Proof of correctness. If m comma w and m dash comma w dash is unstable, as m prefers w dash more than w, it must have proposed to w dash before. But in a later round, w dash have a worse match. This contradicts the above lemma, and hence our algorithm is correct.
The ordering here initially was strict.
Ordering is strict. As it turns out, on partial ordering, it's NP complete. But what do we do when the gender is not a constraint? We are running a friendship process. We are not trying to make up. Let's rephrase. We have two n people with complete preference over the others. How do we find a stable matching? What does stable mean in this context should be a better question now. Because gender has been dropped. Right? If your matching is stable, if no two participants prefer the other over their match, basically if let's say I match you both and you both, it should not happen that you both can run away together, ditching these both. Something like this, it should not happen for any pairs, right? Makes sense. You can formalize this with a few symbols here and there, but makes sense. This does not even always exist. Consider this. A likes B more free fitting, so on so forth. Consider any matching, and you can see that a contradiction can be found. There is no stability which can occur. This is what sort of makes this problem harder. However, as it turns out, roughly a few years after the first scheme, deferred acceptance scheme, we found that this can also be solved in quadratic time. In quadratic time, if there is a stable matching, we can produce it. If it's not there, we can show it's not there. It was found by Robert Irving in 1985. Again, the 2012 prize was a bit controversial again because Irving was also not considered for it. Why was he not considered? No one knows. Okay, this algorithm happens in three phases. First phase is very similar to Gale-Shapley. Again, any resemblance to any copyrighted material is purely coincidental. These are just names which came out to be randomly in my head. Nothing. No one should any. Yeah. Okay. Now Ross proposes to Rachel. Rachel proposes to Joey. Everyone is keeping two proposals, one incoming and one outgoing. If that makes sense. Now here if Chandler proposes to Joey, and Joey likes Rachel more than Chandler, so he rejects Chandler outright. Fact. Chandler now proposes to Phoebe. Monica proposes to Ross. Joey proposes to Ross.
Oh, is it the second one which is the first one?
In
How
this-
did Chandler after proposing to Joey get another proposal?
No, we are just doing it till we have everyone have one incoming arrow and one outgoing arrow. We are.
Oh, we are not doing it in round out.
No, we are not
Yeah,
doing
yeah,
it.
yeah.
We are just doing it on the spot. Yeah. and the same set of things. Okay. The second wave of algorithm is rejecting all people below your current proposal. If the current incoming proposal you have, everyone below it you reject. You're like, at least itna to meko mil raha hai. Anyone below that should be rejected. For example, Raf's incoming proposal is Joey, so he does not get to reject anyone. Rachel's incoming proposal is Ross, so she rejects Chandler. And so on and so forth. Create that part by. Now notice any singleton list indicate that this is their only possible match. So we want to try to get singletons, right? If there was singleton, that just says that this is the only possible match. If we try to match them with anyone else, instability can be created. Great. The third wave of the algorithm is eliminating cycles. Notice Ross likes Rachel, Rachel likes Joey, Joey likes Ross. So we can try to get their match. We can try to get their into singleton lists by removing last element in a stable manner. If any of the list goes to 0, which means no stable matching list. Basically, ouch. Yeah.
So it is basically after that we are looking at cycles and
Yeah. We are looking at cycles. We are just eliminating the complete cycle out by eliminating certain number of these matches in some cases. Okay. Proof of correctness and complexity are much harder. They take up around 4 or 5 pages of the paper, and it's certainly a dense paper. So, but the idea is roughly the same as the last. We just show that in round t plus 1, you cannot have a worse provisional match in round 1, round 2, or round. In phase 1, phase 4, phase 3 of the algorithm. And then you just use the, you just show contradiction if the algorithm was false. The complexity of O of n square, we have nowhere made anything more than that. Yeah. But this is an extremely complicated algorithm. The official Python implementation is 75 plus lines, removing all comments and empty lines, and collating things as much as possible. The same can be said for the Java, C++, and R implementations. So why use Haskell for this? Why Haskell? Yeah. These are the real reasons for why Haskell. But I'll try to give better reasons. Jokes aside. Haskell is a functional programming language. Okay, how many people have not heard the word functional programming? Can you please raise your hands? Okay. Functional programming means that everything in the language is a function. It is a mathematical function. You can only give it an input and it will give out an output. For example, in Python, you can give if, this, then that, do, for loop, for this, do this, sort of. You are giving instructions to the language. In a functional language, you are saying, I call this function. Now it is up to the language if it wants to call something and when it wants to evaluate. Haskell is a lazy language, as in it will not evaluate something till it absolutely needs to, which comes with its own sets of benefits. Now, it is functional languages tend to be better when dealing with more complicated algorithms, because we can compose functions with each other, which is one thing. And second, we have higher order functions which take functions as fold, map, zip, etc. I think map is a pretty common function in other languages also now. Zip is just, you are given two lists, take one element from this list, one from this list, make a tuple, put it in a new list, continue. Now we can have a function called zip width, which will, instead of making a tuple, apply some operation onto this. Makes sense? Some ideas. I will also point out that the next pieces of code are almost being read after a year. I probably will understand all of it because Haskell is a great language. If I don't, please blame me, not the language. Phase 1 of Irving. Okay, lot of scary shit. Let's see what is happening. Irving 1, people. People is something, is a list of the size of the type, that's just a type. That we have a tuple of string, the name of the person, and another list inside which is their preference order. Make sense? Great. So what do? We call a new function called go, which first forms a map from this entire thing, the for easy access. Convert this list to a map. Then we get an empty map, and then we just get a list of people. Map first people, and just take the names of the people. Makes sense? Where let's see what does this new function code. Go references, ANF means my answer, what I want to output, empty. If this list ever becomes empty, if the number of people I need to process becomes empty, which means I've done all the work, yeah, in that case I'll just say m dot just give me a tuple of the answer, comma, whatever preferences is null after rejection. Does that make sense? Great. If it is not empty, what we will do? We'll find this person. If their list is empty, we'll delete them from this procedure. Okay, you have no one to propose to. Eventually the algorithm will look at this empty list and reject this entire thing out. If I reject it now, I'll need to make an error call somewhere, something. Too much work. When we look for empty things, we'll reject it there. Make sense? Remember we said somewhere that if we get an empty thing, we'll reject. So if someone's preference becomes empty, we'll just delete them from the list and say, okay, we'll look at you later. Screw you. Otherwise, p.ps, if the first person is p, then it's just the proposal logic. If there is no one who has proposed to p till now, just add if m dot not member p answer, then go to blah 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 blah. If someone has proposed, then just check that if p rejects b dash, if p rejects b, if p rejects, this should be if b rejects p and if b dash rejects something else. Make sense? 4 cases, 4 statements. Done. And then in that case, we just check this statement is applicable. Please note that it's written mathematically. Let blah 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 in blah blah blah. Make sense? Great. Phase 1 done. Phase 2. Rejection is just me. I just wrote a function to tell me if this is my best, delete everything below it. So I don't need to write more work. I don't need to write things below. And if you look here, it is just us going to the preference list and the pairs. And if the pairs gets empty, we have processed everything, we'll give out an answer. If something is left, we go inside the answer, we find it, and we remove rejects. And remove rejects is just a function below, which says everything below should be removed. And all of the functions uses the rejection function as a sub-function, if that makes sense. Just words. Finally, table stable. If empty list is not an element of the, if the empty list is not an element, table is stable. If it is, then gives false and
Can you go back to last slide?
yes sir. And
Okay.
make sense? Yeah. Are we done? If all the lists are of size 1, we are done. That's our flag. And then this is all again I was asking you, okay. If are we done gets called, if are we done comes out to be true, output done, okay, detect cycle is just detecting a cycle. Yes, this is the last part. Are we done is equal to blah blah blah. Okay, in math you have seen the case notation, right? Function blah blah and equal to. Right, that's just the case notation. Are we done press, if are we done press if true, then we go into this case, which is of outputting. If table is not stable, give out an error, no stable matching found. Otherwise, this. And where we have defined our go function will work. Make sense? Okay. If you want to look at the complete code with more comments than whatever is here, it's on my GitHub. And finally, we can just compose all of them with dots, dot, dot. Dollar just means that put a bracket around everything. Which comes out. And NumPy just to, because 2 pairs will be there both ways, so I'll just reject it. I'm just cutting half the pairs. Basically, A is with B and B is with A. I don't want both of them on this. That does the algo part of this. This is everything regarding the algorithms.
Why use Haskell?
Why use Haskell? Oh, okay. This is, if you count the number of lines, this is much shorter. It's also easier to debug for at least. Yeah.
Okay, number of lines might be sure that maybe that. Even though it looks a little bit more complicated to my age. But the thing is, Haskell is much slower than C and C++. It's like, depending on how optimally you're writing it code, it can be up to 50% to 10 times slower than C++. And for larger scale applications, if you were to do this on a much larger list, we still write it in Haskell, you will obviously switch to C++.
Yeah.
And in that efficiency ends up mattering. So, and the second thing is, in using Haskell, you do give up a lot of your access to certain data structures and certain low-level memory managements. What does it offer that compensates for not being able to do something like?
One is Haskell is much more safer. I mean, odds of you creating a memory error is low.
Not using double pointers. You
Yeah.
can avoid using double pointers in C.
Sort of. And second is, like Haskell is simpler at least to me to work. Just one, like, the Irving algorithm is just a bunch of functions, right? Okay, if there is a cycle, do this. If there is this, it's just a function. It's just a bunch of flagging functions.
I
Yeah.
get that part. But do you use Haskell when you have to make you have to solve a problem by yourself first up from bottom up, or do you use some other language and then try to rewrite the code in Haskell?
I normally use Haskell. Okay, I normally switch between Haskell and Python based on if the problem is like very imperative, if the problem is calling for a for loop, I prefer using Python just to get it done. But if it is functional in nature, I try to like to use Haskell. Anyways, let's reasoning about data. So okay, CMI campus in general is a bunch of people who don't like doing things. It's a lazy math campus. It is so lazy that a bunch of people will not even wake up during its holiday. Emptiness can be seen in all corridors. I hope. So somehow I convinced 56% of the people on campus to give me their data. I convinced them to go click on a link, fill out 60 questions, and give me permission to sell their data. I did not sell their data. 33% of Indians are on social media, 52% Indians have access to internet, 55% of Indians eat meat, and 56% of CMI took part. Okay, this was done by bombarding people with a lot of myths. And telling shit like only 28 hours left from closest in 200 minutes. And yeah, this is our response graph. These are all people who had taken part before last year. And this is the last call. Anyways, the point is you can have the best matching algorithm in the world. Doesn't matter unless you can get people to give you their data or take part. We are not trying to steal people's data. So yeah, I am not the best marketer, but there's something worth keeping in mind for this kind of things. If people need to view something 6 times before they pay attention to it. Yeah, people need to believe that this is really happening. If the questions are somewhat stupid, people won't believe it and then believe it's fake. Reduce the friction. Please don't ask for download sign-ups. Very long responses. Try to convince them that it will not be very long. And make it fun. At the end, humans do things for fun. That's it. Yeah. Only do with data what you claim to do. The higher the intervention, the higher the burden of ethics should be. The second point is pretty important in this. Okay, in this case it's just a fun thing. I'm just matching people with a friend and being like, okay. So in this case I don't need to pay a lot of attention to where the data is going. But have anyone heard of kidney matching? Have anyone heard of kidney matching? A lot of work is happening in the regard. Can we find kidney donors using algorithms? In such cases, it becomes extremely important that the data is handled very ethically and very secure. And yeah, make policies to make sure you are incentivized to do the right thing. The privacy policy for this entire thing was 66 words. The 66 words read whatever is written here. Yeah. Anyways, another reason is, have anyone given BuzzFeed tests? Everyone has given BuzzFeed? Yeah? What? You're not even BuzzFeed.
How old are you?
How old are you?
I'm 16. Like 16 to 17.
Okay, I think these people were way younger when BuzzFeed or 4 or 5 years ago.
No, I'm not that old.
Yeah. Okay.
BuzzFeed is so much people think now.
God. Okay. BuzzFeed used to be this very weird popular website, which was the pick like 8 of your favorite foods and we will reveal your true career path. Do shopping and we'll tell you who your favorite princess is. What?
I've seen some.
Sure. So the point is that people used to enjoy this website a lot. I don't know how much people use it nowadays. I don't. Another thing is, okay, I don't know.
What?
It's an old slide. I don't know. Okay, yeah. So some people found these quizzes so fun that they made it their research interest, and that entire thing is called psychometrics. There's something similar called Stanford Marriage Pact. That was the first slide, the first video we saw. So here we are basically asking you we are asking you to give some information about you, and that leads to two immediate questions. How many questions to ask people? How many options to give people? Yeah. You reviewed your.
No.
Oh, okay. We have to balance between both information and fiction. Also, people are not perfect evaluators. There is something worth keeping in mind that if I, let's say, give you a scale from 0 to 100 and ask you, what do you think? How well dressed are you? Can you tell me the difference between a 69 and 72? Not really, right?
Could you repeat the question? We'll catch you.
If let's say a question was, how well dressed are you? 0 is extremely badly dressed, 100 is very well dressed. Can you differentiate between a 69 and a 72? Not really, right? Most people cannot. And that is the issue, right? We cannot ask people for a lot of, like in theory we can say that people can evaluate themselves from a real number from 0 to 100 and infinite precision. Is that logically even possible? Not really. As it turns out, I gave a 10-point scale. I was later told that 2 raised to n plus 1 scales are normally the best option. Who else likes to put a 2 raised to n plus 1 scale, a 5 scale or a 9 scale? Must be. Anyways, another question is, why do people lie on these questions? Yes, they do. Average height in US is the solid graph. OkCupid was the dating site. All the minors can close their eyes. I don't know. क्या बोलूं?
Abhi, it's fine. They can look at stats.
Basically, people lie about their height on dating apps by rough 2 inches. Okay, question. This person here is 6'4". Why would they lie to be 6'6"? Can anyone try to guess? Data show that people, irrespective of their height, tend to lie about their heights on dating apps. Even tall people. Why?
They want to know what?
If it's universal standard, then people will think that everyone is increasing the height by 2 inches. So if you think that you actually is 6'4", people will think it's 6'2".
Exactly. Basically, if everyone is lying, even if you're telling the truth, someone else who is reading the report will think you are lying. Basically, let's say I say my height is 5'2". As everyone is lying, someone will think, no, this person is 5'5" only. But it should instead say 5'4". So now they think I am 5'2". And this is a problem, right? Everyone is lying. We don't want that. Even worse. Portion of photos which are at least m months old. People once they get a good picture, don't change it for huge amounts of time. Which is again, we do not want that. We want people to constantly be updating it, have the information be somewhat up to date. So what can be done about it? Asking the right questions. If I ask the question, I am funny, agree or disagree. If I ask you to judge yourself on are you funny, and I told you that you are going to be matched on similarity, most people will just tend to move towards I agree, because to a rational actor, someone whose entire goal is to get as good of a match as possible, it reads as I am funny and please match me with other funny, right? So we cannot ask that as a question, unfortunately. We can ask questions like social activism and making a difference are important too, because lying on this has no benefits on either side of the spectrum. If it does not matter to you and I match you with someone it does matter to you, it's not going to work out well for you. Or even more benign, I am a night owl. Why would you lie on this? There's no benefits to be gained. Similar, or for example, I spent significant time on online communities. The idea is that questions should be such that respondents are not incentivized to lie or misrepresent. And Now we come back to mathematics. Psychology हो गया. Yay. Now we are back to math. How much information have I tell you? Let's see, I got a graph of this sort. How much information have I gained about the people I was serving? Have I gained much information?
Can you tell me what the scale is?
10 if I agree, 1 if I don't agree. Strongly agree, strongly don't agree. They have not given me much information, right, about the people. They have told me, in generally, people in CMI are open to friends of all gender identity and sexual orientation. Not much has been known given me. What about this? Does this tell me a lot? I am comfortable with my friends smoking cigarettes. Has this given me a lot of information? What about, has this given me a lot of information?
Will you go back to the last slide?
Yeah.
I don't know the question, because this is the first time seeing a almost normal looking graph just dipping very low at the middle point.
What about this one? Like, does this give us a lot of information, right? This allows us to almost partition people into buckets pretty quickly. And in pretty clean manner. What about this? This also gives a lot of information.
Like I have a question, even if you it allows you to bucket people into buckets, like somebody is uncomfortable, somebody is very comfortable. Again, in this scale, what is the difference between 1 and a 2 except for uncertainty? Like maybe it is fine.
Not much.
So how do you still partition it? It doesn't give you any information.
Come into that.
Okay.
A very lopsided distribution does not tell us much. It tells us, like, if everything has gone towards one side, the question is pretty much redundant, right? I could have just removed it. If everyone has put a 10, just remove it, right? What am I thinking? Ideally, you want questions to have almost even distribution because it just distinguishes people. What you are telling about 1 and 2 is something we have to deal with when we choose a metric for comparison. Makes sense? Right. Although some questions are important enough that we have to put them there. But anyways, is there a way to measure this? Variance does not work. This is an extremely lopsided distribution, have a variance of 4.5. This is a decently normalish distribution with 1 here, which has a 4.5 variance. If I was choosing my questions based on variance from previous year, these both would look the same to me. A method of evaluating this was suggested by Professor Rajiva Kanandikar, who will give a much better talk just after this, which is called Wasserstein metric or earth move of distance. The idea is, consider a bar graph, which happens to be a pile of earth. If we just put things in this shape. How much movement do we need to make these piles even? We define movement as the number of points we need to move into the average distance we move. This can be computed by a very nice recursion in pause n time, where n is the number of options we have. For example, in this case, this has very high EMD. This tells us that it is extremely lopsided, while this has slightly lower EMD. It's more even in comparison. Does this make sense? Why we have used EMD over, say, variance?
Can't we use like kurtosis?
No. I can generate skewed kurtosis is also prone to such errors. Like I think this example will break on kurtosis as well. I tried till fifth moment, nothing else. The reason is EMD works because it literally just moving people. Anything else, a counterexample can be created. One argument can be how rare is a counterexample in actual population. I have no idea how we can calculate. Now let's talk about the difference between 1 and 2 and let's say we have 3 people, Alice, Bob and Carol, and these are their responses to certain things. Who are the closest among these two? Bob and Carol are the closest if we take the Euclidean distance. Seems like geometry. Alice and Bob are the closest because they are the same person. Just Bob is double enthusiastic about everything. And Alice and Carol are the same people because they are just like 1, 1, 2, 2, 3, 3. Just a small difference on the last one. Which answer is right? Who are the 2 closest people here? Is a question worth asking. And as it turns out, all of them are close all of these are somewhat correct. We cannot call any of the answers wrong way of measuring, if that makes sense. Given all of our points in a 64-dimensional space, there are some questions. How do we define the distance between people? We need a metric. Problem is every metric imposes some idea of what two people being close means. Additionally, we have a requirement that computing the distance between 2 points should be fast. I need to compute a lot of distances. If this is slow, then the entire thing will grind to a halt. So the problem is the speed requirement does not narrow our options down. So what do? We are going to philosophy. Have anyone heard of this comedy special called Jigsaw?
No. Daniel's class, right?
Yeah. Yeah, it is famous for causing a lot of breakups and divorces. 500,000 breakups, more than 1,000 divorces. Daniel stopped counting in 2022. And an excellent analogy of what I believe love and friendship are. While I will not spoil much, the answer is that the argument Daniel presents is that we are all trying to assemble the jigsaw of our lives, and some pieces are missing and some pieces are extra. The problem is we cannot treat someone else as just extra pieces. That's the problem. They are their own complex person. The only case the pieces will fit is if your jigsaw are similar or compatible enough but different enough to have blah blah blah. This leads to the decision to use a linear combination of mean absolute difference and Pearson correlation. What are these two things? Pearson correlation is just the taking how similar is the pattern of responses. 1, 2, 3, 4, 2, 4, 6, 8 are very closely correlated according to them. These are very similar. But we would argue that these are both very different people for our argument. Because in this case, this person, in 3 and 4, this person is on the disagreeing side of things. They disagree with statement 3 and 4. But 6 and 8, they do agree with it. The biggest problem with mean absolute difference is that 1, 2, 3, 4, from the POV of 1, 2, 3, 4, if 1, 2, 3, 10 is closer to them than 3, 4, 5, 6. Balki 3, 4, 5, 6 is much more similar to them than 1, 2, 3, 10. So we can fix both the issues by combining these metrics. This will lead people who have similar patterns but and are also close-ish enough to each other. The way I chose the ratio of backtesting, I ran it on the last year's data and to see if the matches which are getting make sense. This is perhaps the most non-rigorous part of this. The biggest issue is quantifying the quality of matches without a metric as we are choosing a metric to begin. I spent a lot of time on this. I don't have any better idea than just moving numbers around and seeing if it's quote-unquote better.
By the way, I had a thing to ask.
Yeah.
Can't we devise such an algo? How do we compute if they're like if they're adjacent or like they're close by? So it is not linear. Like in mean, we are taking the linear stuff, but we are doing some kind of exponential or like higher degree term. So 4 and 5 is not like much different, but 4 and 10 is like if there is like 1, 4, 5 and 1 is 5, 6. So it's like good, but if we have like 1 is 5, 5, but 1 is 4, 10, that is way worse because they're like the degree terms are more. So can't we define such a algo function?
Last time when I presented it at the student seminar, someone did suggest that this can be done better by deep learning or some machine learning strategy, which will eventually set up such an like closeness metric, which will probably be using something of this sort, something like that. But I am not very versed with machine learning. What I'm saying is we keep looking at data and we keep fine-tuning our things again.
Yeah.
That's just machine learning. Okay. Now to data analysis. Is there any confusion on the previous ones? Okay. Findings. Political. We can see these kind of things do act as political surveys because people are much more likely to be honest on this than on an actual political side. Because I don't know. I have no idea. We were able to see a negative correlation between political acceptance and dislike of billionaires. People who tend to hate billionaires tend to also hate people who like billionaires. We also were able to see a positive correlation in all people who are comfortable with drinking, smoking and drugs. If you do one, you will probably be interested in one. Party hosts are also societally conscious people. I love planning and hosting parties when social activism have a high correlation. People comfortable with drinking are more likely to be LGBTQ friendly in comparison with those comfortable with drugs or cigarettes. And we get a lot more, but I am not putting them up because these were the most interesting ones I found.
You said that people who drink and have a very high positive correlation with people who like smoking cigarettes, and then you're saying that people who like smoking cigarettes are not LGBTQIA plus friendly.
Yeah.
If you go back and you say, I have two questions to ask you. Firstly, how many people who like the first thing but do not like the second thing, and these are them? Like people who smoke but don't drink, and people who drink and don't smoke. How many people, what percentage of your responses were in from this group?
I did not realize that.
So if you have two responses, and that is a skewed data, it's not a relevant data metric. If you have two three responses,
I think, yeah, the reason I think that no p-value is given there is because I think the p-value was not good as far as I know.
yeah.
With others, I think the p-value was just coming very strong. Yeah, probably that's the reason I'm not given a p-value there. But I think there are enough people who come in all the
If you remember
vendors.
the original graph, for the people who are not LGBTQIA plus friendly,
Uh,
they were less than, I would say, under 5, which I would go for, would be less than what, 15 people out of the response sheet of
Yeah.
close to 150 to 200.
yeah.
So, out of 15 people, and then again, people who smoke cigarettes, very small list. So, बहुत कम लोग हैं. I think this is just one or two people जिन्हें बोलते कि हमें नहीं अच्छा लगता, this skewed your
That's
attention.
skewed.
It's not a valid metric.
Makes sense. So maybe this statement is somewhat false.
Yeah.
Makes sense. Yeah, another thing is this is one of the very weirdly lopsided things I found. Is following specific sport or team is a major hobby for me. Yeah, CMI most people are like 9, but those who follow are like very. Financial stability is more important to me than chasing passion projects.
So why are you see money? Like we like passing, right?
Yeah.
And that's why.
Yeah, therefore you can see na, that most people are close to this side of the spectrum.
Oh, that's a topic. I thought you were writing as a joke for you.
But if you look at the data from just 1 year back, so this is last year data, you get this kind of spread. I think this is more due to the fact that the data science batch was more active during last year. And data science was placement building. That is our theory for that. So this was another change. This is data which I feel one should buy from local businesses over large corporations. And this is data from last year. Yeah, people have turned against. I believe billionaires should not exist. Last year looked like this. This year people are like much more late for billionaires. People, I love celebrating birthdays and important milestones with my friends. Last year looked like this, and this year it looks like this. So people want to party, but not very much. The change is only by 0.3 points. And this was the question with the most change in response. That was the last year. Okay, principal component analysis. Again, have anyone heard of this before? No. One person has heard of it. Okay, yeah. Basically, we cannot imagine anything beyond 3 dimensions, right? But all data collected here is projecting things onto a 64-dimensional space. So if I ask you to think of all the people in this space, our brains are not meant for that. What we can do is we can take all the data, we can find the axis, find a basis where the variance is maximized, and we can reduce the dimension by 1. Keep doing that till we come to 3 dimensions or 2 dimensions. If that makes sense. So basically, get the entire thing down to principal component. This is what we get as a PCA projection. This red dot is me. Basically, we got everything down to 2 dimensions. And both of these are linear combinations of other 64 dimensions. If that makes sense, right? We just keep reducing one dimension after the other, trying to keep as much variance as possible. That's one thing we're maintaining. One way of getting outliers is by making a convex for object. Okay. We can see Abhinav Negi is out there. Have everyone met Negi?
Yeah, that you understand.
Ishan you will not get to meet, I think. Palak, not. Okay, Sampriti will probably meet. Harshita. Convex is what. It's just the large, like just take a rubber band around it and drop it. This person you will meet for the poker night. Rishikesh, I don't think you'll get to meet. Gautam is this person. Yeah. And these are the 5 most CMI people. These are the centroid. We just took the centroid of everything and we just found the closest things to the
Who is Saurabh?
Forest is my data science 1.
DS2.
DS2. Anushka is also DS2. Priyanshu, I think you guys met. Some of you may have met.
He was playing poker with you all yesterday in the common.
If people were playing poker.
Okay.
Vasudev will probably meet. Anvesh will probably meet.
Unless if you all play football, probably.
Yeah, play football.
But there is football. I can't be there.
What distribution of volume? These are just the things which were the components to the piece. Okay. How much we multiplied it by adding it to the 2D prediction. Conclusion. Okay. When I began with this last January, it was January 25, I was looking for a quick pastime to get the fact that I do not know why I took maths. Okay, I think Piyush mentioned this. I was in biology before I switched. I did my 11th in PCB, in 12th I switched to PCB. Yeah, I did not know why I was doing. And everyone in CMI normally knows what they are doing. There are people who come here day one, they are like, I do number theory. There are people who do logic, people who do algorithms, people who do algebra geometry. I did not know. So, yeah. So, to some extent, this project did tell me what kind of stuff I enjoy. Yeah, furthermore, it helped me speak with a lot of people at CMI. I used to just find people and ask them, whom did you get matched with? Also, doing this in Haskell made me understand what a lot of production Haskell tends to look like. Some things have been cut because there's, like, when you process input files, you use monads. Like CSP and all force some amount of monads. But yeah. The data analysis gave me appreciation for the DS people.
Where is Piyush in like that?
Oh, I do not know. He's somewhere.
Piyush is more like, let me check another.
Also, every reading project I ever got and I have discussed this with the prof, and they tend to enjoy this. So yeah, if anything is to take away, just to cool down shit. Few things, few reviews we got was, take care. Thanks for listening to me. I want to go to sleep because this was being made early in the morning today. Yeah, done.